Good morning, MAB Elementary. It's Mr. T here for an astronomy lesson. You know, in the course of our 3-year curriculum cycle, where guys come to us in the first year and stay till the third year, we explore 7 of the basic sciences in our cultural groups. Astronomy is probably Mr. T's favorite, although I do like zoology a lot. Mr. Smith likes geology and human anatomy. And Mrs. Kiefer enjoys chemistry, and of course, she's the artist in our family. So we have all these wonderful opportunities at MAB Elementary, and I want to continue our lessons in astronomy today. We're getting close to the end for this term, but we still have the major character in our solar system that we haven't explored in detail. It's our star, the sun. So that's what we're going to talk about today, and we're going to learn a lot about our star and our sun, which is the core to our solar system. So let's go back and remember. Our sun's a star. It's a yellow star. It's a medium-sized star. It's a third-generation star. It's important to remember that, okay? Because our sun, our star, was not a result of the Big Bang. Big Bang happened 13.6 billion years ago, and the stars that were formed from the results of the Big Bang were born, went through their life cycle of solar nucleosynthesis, and then died. And they died as a supernova, and that supernova thrust the dust and the energy and the elements of the stars out into the nebula, and it formed a new star, and the whole process began again. So that happens 3 times to produce our sun. And so our sun is about 4.6 billion years old. It's a medium-sized star, which is a long-lived star, and that's good for our solar system because it means that our sun will continue to burn and produce energy for probably another 5 billion years, which is a real long time. So where is our sun located in our solar system? Well, you've seen the pictures, and you can go back and look at them, of our Milky Way galaxy. I mean, the drawings of it. So our Milky Way galaxy is a spiral galaxy with a black hole at the center, and our solar system is about 2/3 of the way out in the wheel from the core of the Milky Way galaxy. And remember, our Earth rotates every 24 hours. So if you're on the equator of our Earth, it goes right around, takes 24 hours. Our galaxy, the big spinning galaxy of the Whirlpool galaxy, is spinning too. It's rotating around, but it takes 226 million years for the galaxy to go all the way around. So the galaxy is huge. So what is our sun? Our sun is this ball of gas. It's about 75% hydrogen, about 25% helium at this stage in its life cycle. And it's a nuclear furnace, a boiling, super hot gas that generates gas particles called plasma, and these evaporate from the crust of the sun, the outer edge of the sun, and it generates a solar wind. And the solar wind builds up at enormous speeds, 470 miles per second, by the time it reaches the Earth. And it takes that plasma, that energy raised from the sun, it takes them 8 minutes to get 93 million miles from the sun to the surface of the Earth. So next time you're outside on a really warm, sunny day and you can feel that sun, that's the plasma on your skin. That plasma left the sun surface 8 minutes ago and traveled 93 million miles. It's amazing. Now, why is that plasma important? Well, that plasma coming to our Earth is necessary for life. Without the energy of the sun shining on our Earth, we couldn't have life on our planet, because that solar energy is what provides the energy for plants to grow. And without plants growing, the herbivores wouldn't have anything to eat. And the herbivores are the cows and the chickens and the pigs and the sheep that produce the meat that carnivores, many human carnivores, like to eat. So this whole interdependence of life on the earth is dependent fundamentally for the energy that comes from our sun. It literally is the source of life on our planet. Is the sun hot? Wow, you have no idea what hot is. So on the surface of the sun, it's 11,000 degrees Fahrenheit. You go outside today, it's about 60 degrees. The surface of the sun is 11,000 degrees Fahrenheit. But that's nothing. Down in the core of the sun, where this nuclear furnace, which is fusing the hydrogen atoms into helium and producing this tremendous amount of energy, the temperature in the core of the sun is estimated to be 27 million degrees Fahrenheit. Super, super hot inside our yellow star, our sun. Size-wise, the sun is 109 times the diameter of the Earth. So if you put the Earth in across the center of the sun, it would take 109 Earths to give you the length of the diameter of the sun. It's 864,000 miles across the center of the sun. And its mass, the amount of matter, the amount of helium and hydrogen atoms in the sun, is equal to 330,000 times the total amount of mass of the Earth. So the Earth is composed of all kinds of heavy elements of carbon and hydrogen and silicon and manganese. That total mass is, the sun is 330,000 times the mass of the Earth. So it's a huge, powerful source of matter that's boiling a tremendous heat to produce solar energy. Just because the numbers are so amazing, I like to use these big numbers. So the mass of the sun is 4.4 million trillion pounds. So that's an infinity street. Now, I mean, that's a hierarchy street number if you've ever seen one. The sun alone equals 99 and 9/10. That's almost all of it. 100% would 100 would be 99.9%, 9% of the mass in our solar system. So if you add up all the other planets, and that includes Jupiter and Saturn, the gaseous giants, you put all the mass that's together in those planets, and that's only 1/10 of 1% of the mass in our solar system. The sun makes up 99.9%. The sun's gravity is 28 times that of the Earth. So a 100-pound man, some of you guys might weigh almost 100 pounds, standing on the surface of the sun. Of course, you couldn't do it because, remember, it's 11,000 degrees Fahrenheit. But if you could, a 100-pound man could stand on the surface of the sun, he would weigh 2,800 pounds. Mr. T, for example, I'd weigh 4,200 pounds because of the force of gravity pulling down on my mass if I was on the surface of the sun. The sun is luminous. It has the characteristic of luminosity. You might recall when we talked about the moon in our most recent lesson, I told you that the moon was non-luminous. It did not have luminosity, which means it doesn't generate light. It's a dark, rocky object orbiting the Earth that reflects the sun. So when you see the moon, you're seeing the light of the sun reflected off of the moon. And the sun, and you can't look at the sun and never look at the sun directly because that plasma coming in can damage your eyes, but the sun is 600,000 times brighter than the moon on its brightest night. So I talked about our Earth, and our Earth rotates every 24 hours. So here in Leesburg, Virginia, right now it's almost noon. At midnight tonight, we'll be around the dark side of the Earth from the sun, and then we'll come around at noon again tomorrow, and we'll be right where we are. 24 hours, the Earth rotates. It takes the sun, which is a sphere, it's a spinning sphere in the cosmos. The sun takes 27 days to rotate. So it takes 27 days to go around the equator. Talked about this energy that the sun produces, because it's a ball of energy, right? And the energy starts at the core, at the nuclear furnace of the sun. And remember, it's 109 times the diameter of the Earth, so it's deep inside the sun. It takes 10 million years for those photons of energy to reach the surface of the sun, and then it takes just over 8 minutes to get from the surface of the sun to your smiling face down here on Earth at the speed of light. So the sunlight, if you go outside today and it's sunny, the sunlight plasma rays that's hitting you is 10 million years old. Origin from the center of the sun, 10 million years ago. Amazing. The ancient people made the sun their primary god. And the reason they did that is because they had no knowledge of science, but they had great fears. And so darkness was a scary time. They had great reverence and anticipation for the sunrise every morning, because they didn't know why, but they knew the sun was really, really important. They didn't understand that the sun was the source of life on the planet they lived on, but they knew the sun was important. And so the Egyptians, for example, worshiped the sun god. They called the sun Ra, and all of the ancient cultures had a very special fear of, because they were afraid the sun would not come back one day and it would be dark forever. They didn't know, but they had great reverence for the sun. One of the characteristics of the sun that's really interesting, and you'll be able to see, I think in the poster that I have posted with this lesson, and that poster is really fascinating. You'll be able to blow it up and see all kinds of great details of scientific information. Many of the facts that I'm giving you here are on that poster, so make sure you have a look at it. Look at the sun spots. The sun spots are dark spots on the sun. They can be as large as 50,000 square miles in area. Remember, square miles is 1 mile by 1 mile by 1 mile, a square 1 mile. And some of the sunspots are that big, 50,000 square miles. And they're created by an unevenness in the magnetic surface of the sun. That the sun is like a giant magnet, and there's uneven magnetic force in some places. And so it's sucking down the plasma of the sun, and it creates these dark spots. And they can last for days or months, and the numbers go up and down. The area of sunspots on the sun goes up and down on a cycle that's about 11 years long. And back in the 17th century, it's recorded in history books that there was an unusual decline in sunspots, and it was called the autumn minimum. And what happens is that the sun was just producing less solar energy for a whole period of several years, and there was no summer in Europe. It was constant winter. So it was called the Little Ice Age. So that's what we know about our sun. It's our source of life in our solar system. We couldn't live without it. It's 4.6 billion years ago. It's going through the life cycle of stars, the solar nuclear synthesis. And what's happening is the hydrogen in its core is fusing. The hydrogen atoms are fusing into helium atoms. And then eventually, and you know from our discussion of the birth and death of stars, those helium atoms will fuse into oxygen and carbon and magnesium and silicon, and eventually the core will turn into iron. And iron can't fuse, And at that point in time, and again, 5 billion years from now, at that point in time, the sun will collapse on itself and become just a neutron star. And by that time, we believe and we hope and we expect that great minds of creative human ability will have found ways to colonize other planets and maybe other solar systems. So human life will continue in a whole new phase sometime in the next 5 billion years. And you guys, as astronomers, may be able to start to figure out how to make that happen. So you guys are the hope as scientists for the future of the whole humankind and what happens when our solar system comes to an end. Astronomy with Mr. T. See you later.